This is a past HSC paper and question. It's actually a little bit more complicated than normal. I have to think through what it is that we know. We know it's a 0.37% increase in mass. So we're talking about relativity here. So mv is m naught times 1.0037, or mv on m naught equals 1.0037. Okay, we're going to store that little bit of information away. Grab out our law, our mass dilation law, and then we want to rearrange this to find velocity. Now to start with, even though it's asking for the velocity in meters per second, I'm actually going to work in units of the velocity of the speed of light, so units of c, because it just makes the algebra a little bit easier. Okay, so let's rearrange this to get the velocities on the other side. So that gives us 1 minus v squared divided by c squared, which is 1, so that's 1 minus v squared. That makes it pretty easy. M naught on mv. Let's square both sides to get rid of the square root sign. M naught on mv, that's all squared. So that's going to give us that, well, actually just v is going to be equal to the square root of 1 minus m naught on mv all squared. And m naught on mv is just the inverse of mv on m naught. So we can whack that into our calculator right now. So the velocity equals the square root of 1. Now, it's 1.0037, but to the power of minus 1, because we want to take the inverse of that, and we want to square all of that. And that gives me my speed of light in terms of c. And now I want to get that into meters per second, so very simply I'm just going to multiply that by the speed of light, 3 by 10 to the 8 meters per second, and that's going to give it to me in meters per second. 1, 2, 3, 4, 5, 6, 7, so 2.57 times 10 to the 7, 2.57 times 10 to the 7 meters per second, and there's my velocity.